Good evening to all of you students. Today I am going to explain the integral domain. Integral domain is nothing but this is a ring with some additional features. So let us see what is the integral domain. And a set R equipped with two binary operations that is, this is R plus dot addition and multiplication and containing at least two elements is called an integral domain. It is called integral domain if it satisfies following properties. It will satisfy some properties. So first property is R plus is an abelian group. This is the first property, means R with addition operation will be an abelian group. So we have already seen these properties in the abelian group. First property is the closure property, that is, if A comma B belongs to this R plus, implies A plus B will also belongs to this R plus. In this situation we can say this set is closed with respect to the binary addition. This is closure property. Second property is associative property. Associative property says if A, B, C, these are the three elements that belongs to this set, then A plus B plus C will be equals to A plus B plus C. Means if these are the three elements, then they will show the associativity with respect to the binary addition. Third property is of identity element, means if A belongs to this R, then there will be an element, let us say E, that will also belongs to this R plus. In this situation we will have A plus E equals to A equals to E plus A. Then in this case E is the identity element. This element will exist and this is known as additive identity. This is known as additive identity property. And the fourth one is, this is inverse element. If A belongs to R plus, then there will be minus A that will also belongs to this R plus. It implies that A plus minus A equals to minus A plus A. This is known as additive inverse. If A belongs to this set, then certainly there will be minus A. Now the fifth property is commutative. Commutative means if A comma B belongs to this R plus, it implies that A plus B equals to B plus A. In this case, this is known as commutative ring with respect to the plus. So this is first property of the integral domain. Now we will see the second property. Second property is R dot is a semi group. Means this set with respect to the multiplication operation will be a semi group. It means it will have two properties. First property is closure. This is closure property. If A comma B belongs to this R dot, it means A dot B equals to, A dot B will also belongs to this R. It means this set is closed with respect to this multiplication operation. Second property is associative property. Associative property says if A comma B comma C belongs to R dot, it means A dot B dot C equals to A dot B dot C. So this is associative property. It means this is the second property and this is semi group. Third property is it will have the distributive law. This is the third property. Third is distributive property. And this property means it will be basically, we can say a dot will be distributive with respect to plus. Means multiplication will be distributive with respect to the plus. It means we will have, if A, B, C belongs to this, then it means we will have A dot B plus C equals to A dot B plus A dot C, and A plus B dot C equals to A dot C plus B dot C. This is left distributive. This is left distributive, and this is right distributive, or this is left distribution law and this is right distribution law. So this is third property of the integral ring. Now the fourth property is ring with unity. It means the ring, this belongs to this. In the set will have a unit element. So this one belongs to R plus dot. So this will be the ring. This is fourth property of integral domain. And fifth property is, this is commutative ring. Commutative ring means this will be commutative with respect to the multiplication. If A comma B belongs to this, then A dot B equals to B dot A. It means this is a commutative ring. So this is fifth property, and the sixth property is ring without zero divisors. This is the very important property. It means this set will be without zero divisors, or without zero divisors, or we can say that if A comma B belongs to this, then A B equals to 0. Means if the product of two non-zero element is 0, in this case if A is not equals to 0 and B is not equals to 0, means it will not have the zero divisor. Zero divisor property will not hold, or we can say this will be the ring without the zero divisor. So this is the sixth property, or we can say this is the only important property, because these five properties 1, 2, 3, 4 and 5 up to fifth property we have already seen in the ring. But this was the property, this is a property of the ring with zero divisor property, means zero divisor will not be there in that particular set. So A not equals to 0 and B not equals to 0. So we can say if any set that is equipped with two binary operations and containing at least two elements is said to be integral domain if it is containing these six properties, if it is satisfying these. Now we will see an example. The most popular example of this is, let z equals to 0, plus minus 1, plus minus 2, plus minus 3 and so on. Let us say this is any set, this is a set of integers. We can check all the properties. So this set of integer is the integral domain, because we can check all the properties for R plus. This will be an abelian group. It will have closure property, associative property for this R plus, identity element, inverse element, commutative property will hold, and we can say that this will be abelian group. And this is the second property for R comma dot. This will be a semi group. We can also check these properties A comma B belongs to this. So these two properties will also be hold. So this second property will also exist. We have already seen. I have already explained this in my previous video. That was the ring width, or that was the definition of the ring. And this is the third property. Multiplication will be distributed with respect to the addition. So we will have this two, left distributive law and the right distributive law. And this is the fourth property. The ring will be with unity, means the set will contain 1. This is unity element. It will be there. Fifth property is commutative ring. This will also hold in this particular set, and this will be without zero divisors. Because if we see the product of two non-zero elements, for example, if we consider 2, 3 that belongs to this, then the product of this will be 6, and which is not equals to 0. It means this is a set without zero divisors. So thank you.